At 8:31 on the morning of June 30th, 2010, David Lusing stood at the mainline valve station outside Hardisty, Alberta, watching a pressure gauge climb toward its operational threshold for the first time. 51 years old, Chief Pipeline Controller, 26 years in liquid hydrocarbon transmission across 3 countries. The pipe beneath his feet ran 3,456 kilometers south, through the Canadian prairies, across the 49th parallel, through the American Great Plains, all the way to the tank farms at Cushing, Oklahoma, and the refineries of Illinois. He had spent 4 years building it. The Keystone Pipeline System achieved first flow at 8:47 that morning. The crude moving through the 914-millimeter diameter steel pipe traveled at 2.1 meters per second, fast enough to cover the entire length of the system in 19 days. The pipe's walls were 7.1 millimeters thick, coated in fusion-bonded epoxy, wrapped in a secondary polyethylene sleeve, buried 1.2 meters below frost line across the Canadian prairie section and 0.9 meters below grade through the American agricultural corridor. Every weld had been X-rayed. Every kilometer had been pressure tested. Every valve station had been commissioned. The oil moved. The continent's energy map shifted with it. To understand why Keystone existed, you have to understand Cushing, Oklahoma, a town of 8,000 people in Payne County, in the geographic center of the United States. In 1912, Cushing sat at the intersection of the first major American oil pipeline network, a hub where crude from Oklahoma's Glen Pool field was gathered, stored, and distributed to refineries across the Midwest. The infrastructure built around Cushing between 1912 and 1930 never fully went away. It was expanded, upgraded, and added to across a century until Cushing became the delivery point for the West Texas Intermediate Crude Oil Futures Contract, the benchmark price that American refiners, traders, and producers used to value every barrel of oil bought and sold in North America. Cushing was not the largest storage hub in America. It was the most consequential. When the WTI futures contract specified delivery at Cushing, it meant that the price of oil at Cushing set the price of oil everywhere in the domestic market. By 2005, a problem had developed. Canadian oil production, driven by the expanding Alberta oil sands, was growing at a rate that the existing pipeline network could not absorb. So the pipelines running south from Alberta into the American Midwest delivered crude to Chicago area refineries with capacity for approximately 1.5 million barrels per day of Canadian supply. Oil sands production was approaching 1.1 million barrels per day and rising toward 2 million. The gap between what Canada could produce and what the existing infrastructure could carry was closing fast. TransCanada Corporation, a Calgary-based energy infrastructure company best known for operating the natural gas mainline that had supplied Eastern Canada since 1958, identified the gap in 2004. Their proposed solution was direct. Build a new dedicated crude oil pipeline from Hardisty, Alberta to Cushing, Oklahoma, with an extension to Gulf Coast refineries in Texas. A single system, a single shipper, a single purpose. They called it Keystone. The regulatory path ran through 2 countries simultaneously. In Canada, the National Energy Board reviewed and approved the Canadian segment in September 2007. A relatively straightforward process for a pipeline running through Alberta and Saskatchewan to the Manitoba border. The American segment required a presidential permit issued by the U.S. State Department because the pipeline crossed an international border. The State Department approved Phase 1 of Keystone in March 2008. Construction began in Canada in 2008 and in the United States in 2009. The Canadian segment covered 1,074 kilometers from Hardisty to the Manitoba-North Dakota border, The American segment continued south through North Dakota, South Dakota, Nebraska, Kansas, and Missouri to Patoka, Illinois, the primary delivery point for Midwest refineries, and onward to Cushing. Total pipe, 3,456 kilometers. Total steel, 435,000 tons. Total workforce at peak construction, 13,000 people across both countries. The welding specification for Keystone required each joint to pass ultrasonic and radiographic inspection before burial. A failed weld was not repaired. It was cut out and replaced entirely. The rejection rate for first-pass welds through the river crossing segments, 3.2%. Each rejected weld represented a full day of rework for a crew of 8. If you want to understand how 13,000 people buried 3,456 kilometers of steel pipe through 2 countries in under 2 years, and what happened the moment it was finished, hit that like button. It helps us bring more stories like this one to more people. Subscribe if you haven't already. Back to Keystone. Cushing received its first Keystone crude on June 30th, 2010. The Patoka, Illinois terminal had come online 3 days earlier. The initial operating capacity of Phase 1, 435,000 barrels per day. The tariff rate for shippers, $4.03 per barrel from Hardisty to Cushing. The economic logic was immediate. Before Keystone, Alberta crude moving to Cushing traveled through a network of interconnected pipelines. The Lakehead system, the Mustang pipeline, the Platte pipeline. Changing hands multiple times, accumulating handling costs and transit time. Keystone delivered the same barrel in a single movement, under a single contract, with a predictable 19-day transit time that shippers could plan inventory around. The Cushing hub began receiving more Canadian crude than it had in its history. Storage tanks that had been operating at 60% capacity filled to 85% within 8 months. The price differential between WTI crude at Cushing and Brent crude on the international market, which had historically run within $3 per barrel in either direction, began to widen. By early 2011, WTI was trading $15 per barrel below Brent. By February 2012, the discount reached $23 per barrel. Cushing had too much oil. The pipelines that moved crude south from Cushing to Gulf Coast refineries, all of them oriented to move crude northward from the Gulf to the Midwest, as the original American infrastructure had been designed, could not clear the volume fast enough. The hub that Keystone had been designed to serve had become congested by Keystone's success. The solution was Phase 3 of the Keystone system, the Gulf Coast extension, and later rebranded as the Gulf Coast Pipeline. TransCanada applied to the State Department in 2008 for a permit to extend Keystone from Cushing south to refineries at Port Arthur and Houston, Texas. This segment, 780 kilometers of 914-millimeter pipe, did not cross an international border and therefore did not require a presidential permit. It required only standard domestic permits from the Army Corps of Engineers and relevant state authorities. Permits were issued. Construction began in August 2012. The Gulf Coast extension came into service in January 2014. Crude that had been accumulating at Cushing began flowing south. The WTI Brent differential compressed from $23 per barrel to under $5 within 18 months. Gulf Coast refineries, built to process heavy sour crude from Venezuela and Mexico, feedstocks that were becoming less reliable as those production systems declined, received a new supply of Canadian heavy crude chemically compatible with their existing refinery configurations. Port Arthur's refinery complex the largest refining center in the United States at 630,000 barrels per day of combined capacity, ran Keystone crude through units that had been underutilized for 4 years, waiting for compatible feedstock. The pipe had found its market. The Keystone system's operational record between 2010 and 2024 included incidents that its critics documented and its operators acknowledged. The most significant: a release of 383,000 gallons of crude oil near Amherst, South Dakota in November 2017, caused by a manufacturing defect in a pipe fitting at a depth of 1.1 meters. The release was contained within the right-of-way, and cleanup required 14 months and the excavation of 50,000 tons of contaminated soil. Pipeline operators describe incidents of this nature using the industry term reportable release, a volume exceeding 5 gallons that reaches the environment. Keystone had 22 reportable releases between 2010 and 2022, totaling approximately 462,000 gallons across the full system over 12 years. The pipeline moved 4.3 billion barrels of crude during the same period. The math of pipeline safety is always ratio math. No other freight mode moves hydrocarbon at lower risk per barrel mile than buried pipeline. That statistical reality does not make individual incidents acceptable to the people whose land sits above the pipe. Both facts are true simultaneously. On October 1st, 2024, TC Energy completed the spin-off of its liquid pipelines business into a separately traded company called South Bow Corporation, the Keystone Pipeline System. All 4 phases, all 4,324 kilometers of operating pipe across Canada and the United States, transferred to South Bow's ownership on that date. TC Energy retained its natural gas infrastructure. South Bow held the oil. David Lusing had retired from the industry in 2019. 9 years after he watched the pressure gauge climb at Hardisty on that June morning. His career had encompassed the full construction and commissioning cycle of a system that, at the time of his retirement, was moving 622,000 barrels of Canadian crude per day to American refineries, 43% more than its original design capacity. He achieved through pump upgrades and drag-reducing agent injection that increased throughput without adding pipe. He lives in Calgary. The pipeline he commissioned runs 3,456 kilometers south of the city where he lives, carrying oil every day of every year through weather and political cycles and regulatory proceedings and corporate restructurings. It has never stopped running. The Keystone Pipeline System today moves Canadian crude to the largest refining complex in the United States. It crosses 2 international borders worth of regulatory history, 30 major river crossings, and the agricultural heartland of 2 countries. Its capacity of 622,000 barrels per day represents approximately 17% of total Canadian crude oil exports. The refineries it serves, in Illinois, Oklahoma, and Texas, process that crude into gasoline, diesel, jet fuel, and petrochemical feedstocks consumed across the American Midwest and Gulf Coast. The pipe is 7.1 millimeters thick. The continental energy system that depends on it is considerably less robust. South Bow Corporation inherited a system with 14 years of operational history, a defined shipper base, contracted tariff revenues, and a replacement cost that no analyst has estimated below $12 billion. It also inherited the deferred question of whether the infrastructure that moves Canadian heavy crude to American refineries represents a long-term asset or a stranded one. A question that oil prices, refinery configurations, and energy transition timelines We'll answer on a schedule that no pipeline operator controls. David Lusing does not follow the stock price. He follows the flow data. The pipe is moving. That is the only number that matters to the people who built it. If this story showed you something about how energy moves between two countries that most people never think about, hit that like button. Every like tells YouTube to show this to more people. Subscribe and turn on notifications. We're documenting the infrastructure that connects Canada to the world, the pipelines, the rail corridors, the port terminals, the power grids. The systems that, if they stopped, Canada would stop. Drop a comment and tell us where you're watching from. Tell us if you've driven across the prairies and seen the right-of-way markers. Tell us if you work in the industry or if you live near the pipe. You're not just a viewer, you're part of the record. Thank you for watching.